Of course, if you want it to be more unique, give more information in the prompt, like how the bunny looks, how it is dressed, how the environment looks, and maybe make it fit your story. Let's say I want to do a cartoon illustration. Let's search the list to see if we have something like that. For example, I can select a soft 3D cartoon environment and see what we get, and the result is this one. Let's search for cute and test this cute cyberpunk style. And we get this illustration. These are good for discovering art styles you might not have thought to try yet. Now let's remove this node and search again. This time we look for iTools Prompt Styler Extra. It is called Extra because it has slots for multiple files and templates. Let's connect it to the positive prompt. For the base file, let's select the Pixaroma file, since that one has the most styles. For the second file, I will use the same one. Let's set both to random, so we get a random combination of two styles. If I run it now, I get something like this. There is no bunny because we added a new node and we did not add a prompt yet. Let's drag a link from the output called Used Templates. This outputs the actual styles that were used. Then search for Preview and add a Preview as text node. Now when I run it, you can see what styles it combined. Reflection with fantasy. Now let's add the prompt, a white bunny holding a rose, and generate again. This time it combined propaganda art style with knitting art, something you probably would not think to combine. Let's select a third file, again the Pixaroma file. For the third style, let's select random, or any other style you want. Now if we look again, it combined Japanese, traditional, sticker, and fine art. Let's run it once more, and we get this gilded fantasy bunny. Pretty cool. Let's try again, and this time we get a cute, minimal line art style. Of course, you can also manually select which styles to combine. For example, let's choose a game asset style combined with low poly, and for the third one, select Atom Punk, and the result is this one. You can also run it multiple times to get different seeds. By now, you should start to get an idea of how styles work. Let's try one last combination. Change low poly to a steampunk style. We get this image because we used a game asset style. If I change the game asset to cute cartoon, I get this cute bunny in a steampunk environment. So create your own styles for the things you use most often, or use ChatGPT or other large language models to generate longer prompts that describe exactly what you need. In the previous chapter, we saw how we can use different prompts to change the style of the image, but if we want a style that the model did not learn, we cannot generate that style. For that, we have the LoRa files, which add extra information to the main model. We talked more about this in episode 13. Let's go to Workflows, and this time let's select workflow number 6, the one with LoRa in the name. This is a simple Z-image text-to-image workflow. In fact, if we remove these nodes, we get exactly workflow 5a that we used before. So let's undo that. What is different here is this LoRa Loader model-only node, which allows us to load a LoRa from our computer. I just changed the color to blue, that is all. The node with trigger words is just a simple note. Again, revisit chapter 13 for more details. So let's go and download a LoRa. I created a LoRa for a girl with white hair, and you can download it from here. After that, navigate to ComfyUI, go to Models, and then open the LoRa's folder. Here we already have one from chapter 13, the SD 1.5 LoRa. Now we create a new folder called Z-image, since this LoRa only works with the Z-image model, and we save the LoRa inside that folder. After the LoRa is downloaded, press the R key to refresh the node definitions. Now if we go to the LoRa Loader, we can select that LoRa. You can see the folder and the LoRa name there, just like for all other LoRas. This is the trigger word that I used when I trained that LoRa. I use that in the prompt, together with more words to describe what I want to generate. Now when I generate, I get this girl with white hair. The LoRa I am using here is a character LoRa. There are also LoRas for styles, objects, or functional ones that speed things up. This also allows you to keep a character consistent, so even if you change the prompt and keep the trigger words, you get the same character, which is very useful. There are many LoRas trained by people online, on sites like Hugging Face or Civit AI. Over time, you can also learn how to train them yourself, either online or locally, if you have enough VRAM. Let's search for Allura on the Civit AI website. Again, if you are from the UK, you will need a VPN to bypass the restrictions they set for your country. Let's go to Models, then we can filter them. Set time period to all. For model type, select LoRa. For base model, select Z-Image Turbo. Now we should see only LoRa's compatible with our base model. We can sort by highest rated. We have quite a few here. Let's pick one at random, maybe this one that lets us create character design sheets. Now we are on the LoRa page. At the top you can see this LoRa is available for different models, but we want the Z-Image version. We check the type to make sure it is a LoRa and that the base model is correct. We also check if it has trigger words or other settings. Then we can download it from here. You must be logged in to download models. We save the LoRa in the same LoRa's folder inside the Z-Image folder. After the download finishes, press the R key to refresh. Now we should be able to see that LoRa in the list and select it. Let's see what else it says about this LoRa so we can learn more. Here it shows the trigger words. I can copy those and paste them in a note so I have them for later. They also give an example prompt showing how to use it. Let's copy that and paste it into the positive prompt. I will remove the beginning and ending quotes. Now let's copy the trigger words and place them here instead of the previous trigger words. We also have a subject, so let's say a white bunny warrior. For art style, maybe I add a 3D render style. The rest looks fine. For the model strength, I will use 1. If it is too strong, I can reduce the weight. For the size, let's make it bigger so we get more details. Now let's run the workflow. We get this character sheet, which is not bad. This could be useful for concept artists to see different angles. Let's run it again with a different seed, and we get this result. Now let's change some things in the prompt. Maybe it is a medieval bunny. For art style, I try a vector art style. Let's run the workflow again. Now we get a different image. This seed does not look that good, so maybe I try another seed to see if I get something better. Again, not perfect, but at least it gives some ideas. Let's go back to Civit AI and look again at models. You can see there are LoRa's for all kinds of things. That does not mean all of them are great. They are trained by people like you and me and shared for free. Depending on the training, some are very good and some are not so good. Training is never perfect. If you want to see how much the LoRa influences the result, we can test that too. Change the seed to fixed and generate once to see the result. In my case, I got this image. Now let's go to the LoRa loader node. Right-click on it and select bypass. Then we run the workflow again with the same settings and prompt. You can see that without the LoRa, we do not get a character sheet anymore. So this LoRa clearly helps with creating multiple characters on a sheet. Remember, a LoRa is like an add-on to the main model. It adds extra training to that model, like the model took a new course and learned how to do character sheets. Hope that helps. I explained ControlNet basics in Chapter 14, but there are models like Z-Image that need different nodes to run ControlNet. Let's go to Workflows, and now I want to open Workflow 4 and also Workflow 7, since both are using ControlNet and you can see the difference. So let's go to the Juggernaut workflow, which is a Stable Diffusion 1.5 model. Here we use a Load Control Net model node, and it is the same node used for SDXL models or Flux models. Then, for ControlNet, we have different models like Depth, Canny, Pose, or other types that control the image generation. Now if we go to the Z-Image Turbo workflow, we have a different node here, called Model Patch Loader. Here we load a ControlNet model, and it is called Union because it has Depth, Canny, and Pose integrated into one single model. So we do not have to keep changing the model. It is one model that does everything it needs. Back in the Juggernaut workflow, we had a preprocessor node that converted our image into a format the ControlNet model understands. For the Z-Image workflow, that part remains the same. We can try different preprocessors like Canny, Depth, or DW Pose, and they will work with this model. For the last part, in the Juggernaut workflow, we had an Apply ControlNet node between the prompts and the K sampler with different parameters. For Z-Image Turbo, the node is different. It is called Qwen Image Diff Synth Control Net. Here we only control the strength, which I set to 0.8 so it is not too strong. Now let's download the required models. By now, you should already have the main models downloaded, either FP8, FP16, or BF16. The principle is the same even if you use a GGUF version or other types. We also need to download the ControlNet model. Because we are not using the Load ControlNet model node, but the Model Patch Loader, we need to place this model in the Model Patches folder. So let's click here to download it. Go to the ComfyUI folder, then to Models, and here you will find the Model Patches folder. Let's save the model here. Wait for it to download, since it is around 3 GB. Also keep in mind that over time, more versions can appear, like version 2 or 3, so always check if there is a newer version available. After the download is finished, press the R key to refresh the node definitions so the model appears in the list. Then select that model from the dropdown. Now we should have everything we need to run the workflow. I have here, in the Load Image node, a robot image loaded. For the preprocessor, I use Depth or Canny, but let's start with Canny. For the resolution, I will make it bigger so the Canny map has better details. Then for the prompt, we describe what we want to get, and then we run the workflow. Now we can see that we got a Canny map that ControlNet understands. Look at the result. It looks much better and it follows the edges of the original robot. Let's try with a different image. As you remember, in the input folder, I added some images you can use. So let's say I load this sphere and cube image. For the preprocessor, let's use depth this time. Then let's adjust the prompt to fit. Maybe a green sphere on top of a golden cube in the desert, golden hour, alien. Now, when I run the workflow, I get a depth map for that image. For the most part, it got it right, except the ground. Let's help it understand what I want, so I will add to the prompt the sphere and cube levitate in air. Let's run it again and see if it understands it better. Now we got exactly what we asked for. You can also give the image to ChatGPT and ask for a prompt, together with instructions on how you want it to look. Let's try something else. This time, let's upload that woman in a yoga pose that the Juggernaut model struggled with, to see how much the model advanced in the last 2 years. For the preprocessor, I use the DW Pose preprocessor. For the prompt, I will add a photo of a woman dressed in white doing yoga on top of a mountain. Maybe I add photo taken with a DSLR camera, not sure if it will take that too literally. So now we got our pose skeleton, which looks correct. We also got an Asian woman, which Z-Image tends to generate when you do not specify what kind of woman it is. It also added a DSLR camera on the ground, which I do not want. So let's go back to the prompt. I remove the DSLR part, and for the woman, I add that she is European. Now let's test again. The result is actually great. Same pose, the clothes I asked for, and on the mountains. A perfect result. What do you think? Let's try to recreate this ControlNet workflow so you can practice. Go to Workflows, and let's open Workflow 5a, since this is a simple text-to-image workflow for the Z-Image model. Search for Qwen Image, written as one word. Then select the Diff Synth ControlNet node. Now we need to connect this between the model and the K-sampler, so let's add the links so everything goes through this node. Let's see what other inputs we have here. It says Model Patch, so let's search for that node. We add the Model Patch Loader, and here we select the Union ControlNet model. Now we drag a connection from this node to the ControlNet node. We also need the VAE, and we already know where it is in this workflow, so we connect that as well. All that is left now is an image. To load an image, we use the Load Image node, so search for that node and add it. If we try to connect the image directly, it will not work correctly, because this model is trained with Canny, Depth, and Pose. So we need something to convert the image into those formats. Search for AIO and add the aux preprocessor node. Now our image goes through this preprocessor. From the list, we can select one, for example, the Depth Anything preprocessor. For the resolution, we can increase it a bit to get more detail. Now we connect the output of this node to the ControlNet node, since this is the correct format that ControlNet understands. We can also add a preview node to see how the processed image looks. All that is left now is to adjust the prompt. Let's say the prompt is a modern house in winter. We can also increase the width and height to get more details. Now we are ready to test the workflow. We can see the depth map of the building. We can enlarge it to see it better. The result looks like this. It is similar, but not exactly the same building shape. You could try a more detailed prompt or a different preprocessor. Let's add an image comparer node to see the differences. I want the original image before processing, so I connect it to image A. Then, just after the VAE decode, I connect that output to image B. Now let's run the workflow again and make the image comparer node larger. We can see that it shares some building edges with the original image, but not all of them. If we want more accuracy, we can change the preprocessor. Let's select a canny preprocessor instead. Now when we run it, you can see it captures all the edges in the canny map. The result should be more accurate, and this is the result we get. Now we can see many things in common with the original image. Keep in mind, this is controlled mainly by edges, so it will not be exactly the same building. We can get more control later when we cover edit models, like Flux2, QuinEdit, or Nano Banana Pro. Up to now, everything we did in ComfyUI happened locally, inside the interface. We loaded models, connected nodes, ran workflows, and generated images on our own machine. API nodes are different. They allow ComfyUI to communicate with external services. An API is simply a way for one program to talk to another program over the internet. Instead of doing everything locally, we can send data out, let another service process it, and then receive a result back. Think of it like this. Local nodes are tools on your desk. API nodes are tools you rent remotely. You send instructions, and you get results back. In ComfyUI, you can click on the plus to add a new blank workflow, then double-click on the canvas and search, for example, for ChatGPT. You can see that it says API node under the node name. Let's select this node. Now this node looks different compared to others. It comes already colored in gold, like a VIP version. On top, it tells you how many credits this node will consume, depending on the settings. Those credits change based on what you use. Here we have a list of models from OpenAI that are accessible through the API. The API letters stand for Application Programming Interface. For example, if we select a big model, it can cost between 2 to 8 credits, depending on what you ask from it and how long the answer is. If I change to ChatGPT Mini, it is almost 0 credits. It is not 0, but it is 0 point something, so it is quite cheap. This node has a string output. So like ChatGPT, you ask something and you get a text reply back. Let's drag a link and search for a node that displays text. Search for preview, and we have this preview as text node that we can add. Here we will get our reply from the ChatGPT model. Let's say I ask it to generate a prompt for a cute cartoon bunny, something 3D. Now when I try to run that, it asks me to sign in if I want to use the API. We could use this login button, or we can cancel and go to the menu, then Settings. Here we have the user section in the settings, and again we have the sign in option. Let's click sign in. If you have a ComfyUI account, you can use that, or you can simply log in with Google, which is a faster option for me. Then you select your Gmail email from the list and you will be signed in. Now you also have the option to log out. So now we are connected, but we need credits to run API nodes. Let's go to credits. Credits are like money. You basically use real money to buy credits that you can spend on a lot of models that are available through the API in ComfyUI. I have here some credits I bought a while back. I can click on purchase credits and then it asks me how much I want to spend. For example, I have $10 here, but that might be too much for a beginner to spend on a first try. Let's click on minus to see if we can go lower. The minimum you can buy is 1,055 credits using $5. Then you can click continue to payment. Depending on your country, you have different options to purchase. You can use link, but you can also choose without link if you do not have one set up. Here you have options to pay with a card, or you can use Google Pay if you want, and you also have the option to purchase as a business. Back in ComfyUI, I have enough credits to test a few nodes in today's tutorial. Now when I run the workflow again, this node sends information to the server, wherever those are located in the cloud on OpenAI or somewhere else. Depending on the situation, sometimes it is faster, sometimes it is slower. From the workflow point of view, nothing special is happening. Nodes still connect left to right. Data still flows through cables. The only difference is where the computation happens. Local nodes use your GPU or CPU. API nodes use someone else's hardware. This has advantages and disadvantages. Advantages are that you can use very powerful models that you cannot run locally. You save local VRAM and system resources. Some APIs are faster for specific tasks. Disadvantages are that you depend on an internet connection. There may be usage limits, and of course it costs credits. It is not free. You have less control over model internals. So we got the response from ChatGPT, and it gave us multiple prompts and suggestions instead of a single prompt. So let's refine what we asked and tell it to generate a single prompt. Maybe repeat it once again to reinforce that. Let's run it again. This time we got a single prompt, just like I asked. Now we can copy the prompt and paste it into another workflow if we want. With this node selected, I will use Ctrl+C to copy the node. Then, let's go to Workflows and open a workflow like this, a workflow that uses ZImage Turbo, which we know likes long prompts. I will move this node to the side, then use Ctrl+V to paste that node. To connect this node, we just drag a link to the positive prompt. Now we have a mix of local models that take the prompt from an API node. We can also drag a preview here if we want. Let me search for preview as text. Now we can see what prompt it gave us. I can rename it prompt so I know this is the prompt. Let's run the workflow. You can see it generated a prompt for me, then it continues to the next part of the workflow and generates the image. This can be quite useful. There are free models that can also do this, but we will talk about that in another episode. Let's change the prompt to be a ninja bunny, maybe in an action pose. Generate again. We get a new prompt describing that bunny, and the result is this image. There are many API nodes and many options to connect them. Let's go back to the previous workflow where it was just those two nodes. Now let's add a concatenate node, a node that lets you combine two strings or prompts. Let me remove this prompt. Since we want to get the prompt from the concatenate node, I will use it for string B for now, and then connect this concatenate node here. I will add a green color so it looks like a positive prompt node. For the first part, I write a cute cartoon bunny ninja. For the second part, I write something like, use the prompt to generate a single detailed prompt, creative, adapt the prompt to match the prompt's style and mood. You can use all kinds of ChatGPT formulas here to get exactly what you want. Let's drag a link to a new preview as text node so we can see the result of the concatenate node. Maybe I name it prompt, but I might change that later, still exploring what we can do. When we run it, you can see I forgot to add a separator, so it just combined the ninja prompt with use the prompt to generate. In the end, it still understood and generated the prompt. But let's fix that delimiter and add a comma and a space. Of course, you can split this into multiple nodes and make workflows more complex, one going into another workflow, and so on. This is the prompt that goes into ChatGPT, and this is the prompt that comes out of ChatGPT, the one we want to use in other workflows. Now we can run it again. You can see the input prompt to ChatGPT is this combined text. I like to use concatenate because I can easily change the first prompt without changing the formula below, so it is easier to edit. The result is this long prompt for the ninja bunny. These two nodes are the same, so I only need one and I remove the other. What we did here is split a workflow into multiple pieces, so we can easily edit the prompt without worrying about the formula. I can quickly change the first prompt, run it again, and get a new prompt. It is quite easy to use at the cost of a few cents or 0-point-something credits. I probably do not need that preview anymore since I know how they are combined, so I will leave just one concatenate node, the ChatGPT node, and the preview of the final prompt. Now that we have this, we can save it. Hold Control and drag a selection over all nodes, right-click on the canvas, then use Save Selected as template. Give it a name, maybe ChatGPT prompt, so we know it generates prompts. Now we can paste it into any workflow. Let me open that 5A workflow again. Since it was already open, I will close it because I do not want the extra nodes, then open it again fresh with default values. I move this to the side, right-click on the canvas, go to Node Templates, and now we have that template there. We can move it wherever we want. Remember that the ChatGPT prompt comes from this string output here, and we connect it to any workflow we have to the positive prompt. Now when I run the workflow, ChatGPT generates a prompt. That prompt is used in the Z image workflow, and the result is this cute monk cat. But the ChatGPT model is also a vision model, which means I can give it an image and it can see what is in that image. Let me remove this concatenate node. Let's add a load image node. I upload this image of a helmet. Now we can connect this node to where it says images. It says images because you can add multiple images if you use a batch images node, but maybe we explore that in a future episode. For the prompt, let's say something like, give me a single prompt description for this image. Descriptive prompt. There are more complex formulas, but I am just trying something on the spot. Now let's run the workflow. ChatGPT looks at my image, and after a few seconds, it should give me a prompt based on that image. We got this nice long prompt, and the result is this one. It is not perfectly identical, but with a better formula, we can probably get something even closer. It is still pretty close to what we asked. You can also run the workflow multiple times to get different seeds. Let's see what else we can do. Let's create a new blank workflow. Double-click on the canvas and search for Nano Banana. We have this first version of Nano Banana that is cheaper. It is 8 credits, so you can probably get something similar for free from Google Gemini. We also have Nano Banana Pro, the more powerful model that can do big images. This one costs 28 credits. If we change to 4K size, it will cost 51 credits. Depending on the model, some can cost over 100 credits, so be careful what nodes you use, because you can run out of credits pretty fast. Both accept images, but Nano Banana Pro understands prompts and images better. You can see what model is used for the first Nano Banana, and for Nano Banana Pro, it is actually called Gemini 3 Pro Image. Let's remove the first node and use this one to generate an image. I add a load image node so we can load an image from disk, then connect the nodes. Now I upload an image, for example, this portrait of a man. Then I add the prompt. We did not talk yet about editing models like Flux 2, QuenEdit, or Nano Banana Pro, but these can be used to edit or modify an image. I could say change the t-shirt, or replace the background or hair color. Let's try something simple, like telling it to change what he wears to a steampunk suit. For resolution, for this test I go with 2K since it uses about half the credits. We also have aspect ratio. Instead of auto, I set it to 9:16, but you should use whatever ratio you need. When I run it, I get a prompt failed message. Can you guess why? It says it has no output. That is because we did not save the image. So let's drag a link and add a save image node. I also see it has a string output, so let's add a text preview node to see what it outputs there. Now we can run the workflow again. This one takes longer, over a minute to generate. You can also check your profile here to see how many credits you have, or sign out, manage subscription, and so on. You can also check partner node pricing.